Okay, hey, welcome everyone. What's up, everybody? Thank you for checking in. Please make sure that you have the following note cards either created or will make right now. We're going to need to make the division property of equality. Nothing really on the back of it other than it says that you can divide by equal things. Intercepted arc. You know what? The central angle is equal to the measure of the intercepted arc. Isosceles triangle base angles theorem and its converse. If two sides of a triangle are congruent, then the base angles opposite those sides are congruent. The exterior angle theorem. It says that the two remote interior angles add up to the exterior angle of a triangle. The substitution property, which we've been using all over the place. Anytime we have to make a sub, this is what's doing it. So substitution property, and then make one congruent radii in a circle. You know what? All the radii of the same circle are congruent because that's how a circle is defined. In fact, that should probably be what is the definition of a circle. In page 358, we're going to talk about reasoning abstractly and quantitatively, constructing viable arguments, and then critiquing the reasoning of others. And this is related to our learning targets from page 355, where we're going to talk about the measures of arcs, angles, central angles, inscribed angles. Recall the conjecture you made in a previous topic about the measure of an inscribed arc. Inscribed angle is related to the measure of its intercepted arc. The inscribed angle is half of the measure of the inscribed or the intercepted arc. We can draw inscribed angles formed by two chords in three different ways. So we could draw a chord through the center that makes it a diameter, and then draw another chord kind of off to the side. Or we could draw two chords that put the center in the middle, or we could draw two chords that put the center outside in the exterior of that inscribed angle. Remember, an inscribed angle is an angle whose vertex is on a circle, like P or P or P, and whose sides contain chords. So a chord, a chord, a chord, 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 and chord that touch the other, edge of the circle. So inscribed angles, and it's one of our vocab words from way up there, inscribed angle. And so what we're going to be using with those ones is what we can get with that. The intercepted arc is MT because it's the edge of the circle on the outside edge. And then here's MT, and then here's MT. And the one thing that those intercepted arcs have in common is that they are all minor arcs. Right. Is it possible then? Is it possible to draw an inscribed angle in a different way? Is there another possible way you can draw inscribed angles? It is actually possible to draw an inscribed angle so that you have a major arc. The best way to represent that here would be to pick the middle one. And instead of putting point P over here, so yes, BTW, instead of putting point P on the other side of the circle, put it on the side of the circle where there's a smaller arc. And then there's an inscribed angle. But this inscribed angle is containing less than half of the circle. So then the other arc that goes all the way around MT this way, it would be a major arc. We can construct point P so that point P creates a minor angle. And then the rest of the circle, the intercepted arc is the intercepted arc here. This is a huge intercepted arc. It's bigger than 90 degrees. Construct point P so that the measure of angle MPT is bigger than 90 degrees. These angles are all smaller than 90. Construct point P so that you make an angle bigger. That makes a major arc. Okay, we're going to pause this video here just for the length of time. But reminder, for the next video, you're going to need congruent radii in a circle, substitution property, exterior angle theorem, isosceles triangle base angles theorem, intercepted arc, and division property of equality. Thanks for watching the video. Like, comment, and subscribe. See you in the next one. Bye.